Hello and welcome to the first bauma talk. My name is Stefan Oehme. I'm working for the VDMA, the largest association of companies in Europe building any kinds of machinery. We are supporting the bauma, and this is the bauma. This year, finally, we will meet again. We will have the chance to see each other, and I'm so happy to see you, all of you, in the bauma in October. Here, you are seeing the first bauma talk. What is it? The bauma talk. Basically, the bauma talk is where we want to focus on the most important topics we see for us, for industry in the future. We want to have all experts about for this part or for these topics here and present you the newest insight in their fields of research and what they have learned in the last years. We want to start the bauma talk, the first bauma talk, with the construction methods. So with the view into the future of our industry. Our industry, the building industry, the cement industry, has a major challenge. We are producing something like 8% of the overall CO2 in the world, and this is, as you can imagine, for sure a big challenge. If we would put the cement industry in a country, then the cement industry would be the third largest polluter or emitter of CO2 in the world. So we definitely have the challenge to overcome this situation, and we need to find ways to reduce the CO2 emissions in our industry, and we need to find new building methods. Carbon capture is a very much and many times discussed topic, and we see it has a large potential to reduce the CO2 emissions in the world. But where we are now, what is the state of the art of carbon capture and this technology? Therefore, I like to welcome here Dr. Rudowski. He is working for thyssenkrupp, and he is the head of innovation in thyssenkrupp. And Luke, the stage is yours.
Thank you, Stefan. So Great to Green is the transformation journey we propose to the cement industry. The technologies to produce green cement are available and being implemented, but only carbon capture technologies will allow the carbon neutrality of our industry. And to that regard, 2030 is an industry agreed milestone to start using these technologies. The challenge is to get most efficient technologies implemented at industrial scale as quickly as possible. So my conviction is that we can reach that target as early as 2025, so earlier than 2030, but it's close. To achieve this goal, we need all the stakeholders and industry players to act as one. So, as said, the cement is the first consumed commodity worldwide after water. So more than 4 billion tons per year consumed. It's the cheapest base construction material. And as well, the cement industry is in the public focus for sure, because cement is, let's say, responsible globally of 7% of the global emission. And so that's a huge challenge that the industry has. So there are increasing, let's say, financial implications, well, for sure, public awareness, etc. But there are some increasing financial implications. Polluting companies have an uncertain future, because the environmental and social governance is rewarded by investors. They will discipline the cement players. They will as well reward them if they are going to be greener. There are as well other stakeholders that care: public buyers, green aware buyers, shareholders. And now in Europe, a regulatory frame is set with the emission trading system that is an efficient system to push the industry to make the necessary change. As we can see here with the CO2 price, that is set at a quite high level. It was 80 yesterday. And so then the main European and global cement players have set up their decarbonization roadmaps and a pledge for 2030, as well as a neutrality in 2050. And then, as you can see here, the 2030 is an inflection point with the start of using the carbon capture technology that will have a deep impact in terms of the CO2 footprint, but as well the impact on the business, as you can see, because let's say it will impact the costs of producing the cement. So the challenge is to get the capturing technologies operating at industrial scale as early as possible, and that's what basically we are doing in thyssenkrupp BU Polysius. So and we launched 2 years ago our first set of technologies. So the first thing is that the clinker, which is the let's say binder, main binder for cement, will remain, but it has to be reduced in cement. So one way could be to use activated clay, which is emitting way less CO2. And the second thing is to valorize the remaining clinker share in the cement with the so-called booster mill. The second thing is to use to substitute the fossil fuels by getting a circular economy and burning as a first step, I would say, let's say waste fuel, reuse the waste fuel, that is fuel substitution in our portfolio. And finally, as I said, the greater impact is carbon capture with the use of our pure oxy-fuel technology. So pure oxy-fuel technology will be the gateway for let's say carbon neutrality, and the industry challenge is to implement that in the next 5 years. There is a consensus among all players that oxy-fuel is the best technology. I'm convinced that we will ramp up to be ready earlier than 2030. First important step, thyssenkrupp will build the first industrial oxy-fuel plant with our pure oxy-fuel technology, and that should be commissioned as early as 2024. We have here a representation of typical oxy-fuel plant. So there is no consensus for CCS yet in the industry, especially in Europe, I would say, or easy and economic access to geological storage. CCU and use of CO2 as a feedstock to produce green fuels is probably as well a must to accelerate reaching carbon neutrality. So I think we have to work across the boundaries, and there are recent projects that showcase the potential of sector coupling, such as this Westküste 100 project that we are very proud to be part of, where we are, let's say, combining green hydrogen generation with wind energy, carbon capture in a cement plant in order to produce green aviation fuel. But as well, we rely on CCU.
So thank you again, Luc. It was very nice to have all the spotlights on these new technologies from your side. Carbon capture is a technology for sure supporting the reduction of the CO2 emission in the cement industry. Luc, what is your take on the other possibilities we have available today, like alternative fuels, substitution of clinker? So how much can this other measurements support us in getting a greener cement industry?
Well, I think we need everything, considering that, let's say, cement is the cheapest construction material, but with the challenge of, emitting CO2. Anyhow, we'll need all of them. I mean, to go to carbon neutrality, we'll need to capture the carbon, but we need as well new binders. We will need as well, let's say, to valorize reduce first and valorize the remaining clinker share of it, but as well to go to, let's say, zero fossil fuel use. So we need all of them and many others, by the way.
Yeah, I understand. If we look back to carbon capture, so what is still necessary to get it broader into the market?
Well, we have many challenges, and there CCS and CCU they are different challenges. First of all, there are some countries northern of Europe, for example, where you have access, let's say, to geological storage, and then the infrastructure is already developing, or let's say some of them are very advanced. In the Central Europe or the south of Europe for CCS, we need these geological storages. We need as well the infrastructure, and as well we need, let's say, social and public and political acceptance, which is not the case in some of the countries or of Europe. This is for CCS. CCU, that's another challenge, because on top of the infrastructure to collect the CO2, not only capture, but collect the CO2 and transport it, we need as well to develop along the chain, let's say, the usage technologies. And there we are, let's say, using several technologies at the same time. So the efficiency, well, it's a challenge as well. Last but not least, I think all the actors, stakeholders, public, political frame, etc. We need financing as well. Needs to act in the same direction. So there is a huge challenge in terms of technology development, because we need basically financing to develop these technologies, and then the implementation to get the industrial infrastructure will need time. But I'm positive, I'm optimistic, because the technologies we are very, very close to get them commissioned. So I think it will happen.
Yeah, good. You have mentioned the oxyfuel plants, and that there's a pilot. So I think this is quite interesting for everything. So is there something new in this oxyfuel pilot plant? Is it something where we are getting closer to get this technology rolled out?
Yeah, well, I think generally speaking, I think the industry player agreed that the oxyfuel is the best, let's say, total cost of ownership. So I think they are investing a lot of money to develop this technology. As far as we are concerned, thyssenkrupp, I think we are quite advanced, because we are already working since many, many years. But in particular, we are waiting on the development of a pilot plant, for which we let's say we did already the conceptual and the basic design, and it's a question of days about starting, let's say, the execution of this pilot plant that should be commissioned in 2 years. But okay, that would be let's say a first pilot plant, demonstration plant, let's say, which will be a major milestone. But as well, there are many industrial scale projects where the oxyfuel will be selected. We have at least 4 to 5 ongoing projects right now in Europe.
Interesting. So thanks a lot, Luc, for this insight. And I'm so glad to have you here in the chat as well, that you can answer some questions from our audience in the next minutes. Thanks a lot, and looking forward to see you at bauma this year in October. Thank you, Luc.
Looking forward. Thank you.
3D printing is one topic we're discussing since quite a while, and most likely many people believing that it's still something, especially the architects like to make fancy buildings, round structures. But I think there are some other good reasons to use this technology. Most likely, and this is something I believe as well, it can be faster, it can be maybe cheaper, it can help us to reduce the skilled man force we need on site by building this kind of technology. We can welcome now here Professor Frank Will. He is working in the Technical University of Dresden, and he is researching a lot on 3D printing. And he will give us now some insight about the state of the art in 3D printing. Frank, the stage is yours.
Thank you, Stefan. So, concrete printing has become an extremely visible topic during the last 2 or 3 years, with a huge number of publications in several media. But the vast majority of all these publications is about the contour printing procedure, which is printing of lost formwork most commonly. In contrast, I will focus on the monolithic printing, which means continuous printing of massive load-bearing walls for building structures. And in the video from our lab, you can see the monolithic printing of a corner with layers of 150 by 50 millimeters. Our concept is intended to print massive walls up to 400 by 50 millimeter layer cross-section. But let us start with the question, why does the new concept of concrete printing get such a particular attention? This is because of the well-known challenges in construction: limited productivity, skilled workers shortage, and high number of accidents. All that overlaid, of course, by the most demanding challenges of one of the most demanding challenges of today's mankind, the climate change. And to find an answer to these challenges, we need to develop a consistent digitalized process chain, and we need to increase the degree of automation of construction processes and construction machinery. Concrete printing is one of the most important technologies on this way, with a significant contribution to higher productivity, attractive and safe working conditions. But we have to be honest, regarding the climate compatibility, also the concrete printing still has a long way to go. We definitely need to develop alternative printing materials. So why don't we see more concrete printing in construction practice? I see a bunch of reasons. Probably the most important one are the complex and lengthy approval procedures. Another obstructive aspect is the fact that nobody really has proven the economical effect of concrete printing. It's clearly visible that finally the process will save tremendous cost. But currently we are in a development phase, characterized by prototypes, manual solutions, unstable processes, a low utilization of resources, and single sourcing of specific materials. We are far away from standards, optimized processes, and efficient value chains. I strongly believe in the economical value of concrete printing, but this is based on calculations, estimations, and expectations. No one can provide an evidence under real-life conditions yet. From a technological point of view, most of all, we miss reliable, efficient, and automated solutions for the integration of reinforcement. We can print building structures without reinforcement to up to a certain height, probably 2 or 3 floors. But to exploit the full potential of concrete printing, we definitely need to integrate reinforcement, and the goal must be to integrate it in the automated process, not as today, added more or less manually. Another technological challenge will be integrated solutions for heat insulation and climate control of the building. In the concrete printing process concepts we see today, this is usually a separate process, which cannot be the final solution, of course. To overcome all these obstacles, we need interdisciplinary activities in research institutions and companies, ideally in close cooperation. An interdisciplinary approach is essential here, as several fields of expertise are in close interaction. Not a single person, usually not a single company or a single research institution, can be an expert in the development of materials, machinery, and processes all at the same time. Some of the topics to be handled you can see here on the slide, from different material characteristics causing a conflict of goals, through software development on different levels to create a process from BIM to machine to the building, up to machinery and robotics development. So we at TU Dresden focus on monolithic printing. But why? The major point is quite obvious. With monolithic printing, we gain much higher output than with a contour printing principle. This is illustrated in the diagram where you can see the material output as a function of the printing speed and the layer cross-section. So with the same printing speed, we get a much higher flow rate, multiplication factor 10 to 20. And assuming that you need a certain amount of concrete for the static capacity of a load-bearing wall, you can accelerate the printing process significantly by using the monolithic printing process. Another advantage, due to the larger cross-section of the printhead, we can use material with coarse grain up to 16 millimeter, so we can use more or less standard concrete for the printing process, which is of course much lower in price than some of the super special fine-grain materials used for concrete printing. Also, the approval procedure is expected to be easier and faster when using standard concrete and a structural design which is closer to usual designs and calculations. Coming back to the economic effect of concrete printing, the team at TU Dresden made a comparison between conventional concrete construction, the use of precast elements, and our concept of monolithic wall printing. This comparison is valid for a selected office building. Based on the current level of development, the monolithic concrete printing needs slightly more production time, but there is still a lot of room for improvement. What is clearly visible by now is that the working hours will be reduced by 50% compared to the conventional concrete construction, and still more than 20% compared to precast element wall construction. And we are talking about a new technology at a very early stage, so we can expect significant potential for reduction of production time and working hours. The concept of monolithic printing contains some serious challenges which you don't have in contour printing. For example, the creation of corners, crossings, and T-joints is quite demanding. The same is valid for the integration of reinforcement and thermal insulation. So there is still a way to go. On the other hand, the concept promises significant increase in productivity and a result closer to today's quality expectations and, probably more important, today's building codes. Therefore, we will realize the next development steps together with several industrial partners. In 2016, we presented our first Comprint 3D concept and won the Bauma Innovation Award. In 2022, we will present the latest state of development in Bauma Forum and Bauma Science Hub. At the same time, company Putzmeister will be the first industrial company to show a machinery concept for the realization of Comprint 3D. So stay curious.
Thanks a lot, Frank. Very interesting. 3D printing seems to be something helping us to overcome some challenges we have, and we have talking about productivity as well. Frank, if you compare traditional house building with 3D printing, what is your take on it? So where are the advantages, where are the challenges if you compare it?
So when you talk about the productivity and the time you need for printing a building, I don't believe in all the public statements talking about printing a house in 24 hours, for example. These statements may be right for the net printing time, but there are no stable trouble-free processes yet. So including downtimes and auxiliary processes, we need much more time for this printing. And we are just talking about printing the wall structure of the building. This is just a small part of the complete building. So for me, it is much more important to shorten the complete construction phase by digitalization of the complete process and automation of the machinery. And this is a major leverage effect, and the construction printing or the concrete printing process supports the digitalization and automation of this process.
I see. If we look to let me say this jobs of the future. So if we imagine we have this printings on site and we need people to do it, what will be the skills we need from this new kind of workers on site?
Okay, the number of working hours for hard, unhealthy, and dangerous manual labor will be reduced tremendously. That is clear. On the other hand, we will need more highly skilled people who are also not easy to find, as we all know. But I think we shouldn't overstate this aspect. At the end, we will not have lots of robotics experts, software engineers, and material scientists on site. And this is a challenge for the process and machinery development to find process and machinery to provide systems which can be operated by trained workers with a basic know-how of automated machinery equipment. And in specific situations, we will also need service technicians and quality inspection experts, maybe more than we have today.
Okay, I see. You have mentioned the advantages of monolithic blocks, block printing. This is something, let me say, for me unusual. If I see printed houses, I see all the fancy curves. I see bathrooms integrated in the structure, and I see that a lot of dreams from architects came true. What they can do now. If you take one step back and if you look into this monolithic printing and where we are we ready? Can we have it in the market? Can we print normal houses like we know it with edges, corners in a bigger scale? So is it something you expect for now, or what is your take on it?
So what you describe is one of the major pros for the monolithic printing, because we can print more or less standard architectural things and buildings. And the contour printing is more free in the contours, of course. And the contour printing is much closer to market readiness than the monolithic printing, and we can see it in a lot of pilot projects all over the world. This is maybe because the contour printing principle does contain less technological challenges. Because the monolithic printing is more complex, as I tried to explain, for building edges and T-joints and all these things. And it started in 2014 with an idea at TU Dresden. And since then, a team of 3 chairs is working on development of this process. But it is not on site yet. But the first company to present the machinery equipment which is needed for the Conprint 3D process will be Putzmeister, which we are cooperating with all over the time. But also several other companies were involved in our research. So let us see what else happens in October in bauma.
Do you believe that this is more reliable at the end? Monolithic printing compared to?
Yeah, I'm not sure if it is more reliable, but it's closer to the regulations, closer to the building codes, for example, and that is one reason why I expect the monolithic printing to have a larger market share at the end, and also the material pros and so on. What I expect.
Yeah, I see. Yeah, thanks a lot, Frank. Very interesting insights, and thanks again for having Frank in the chat. So, and this is maybe something for you as well. You can use the chat and ask all your questions to our experts. 3D printing is something new. So it's fancy. It seems to be state of the art. There is a lot of discussions. We can see a lot of pictures. We can see a lot of movies on various media. The question for me is really: is it already reality? Is it usable? And are the machines ready to do it? Can all this 3D printing keep the promises we somehow heard and we got? Therefore, I'm very excited that we have today here somebody who is really somebody who has experience in printing real buildings and parts. So I'd like to welcome Alex Bettenmann. He is working for PERI as the business development manager for 3D printing. And yeah, I'm looking forward to hear your insight, Alex.
Yeah, hi Stefan. Thanks for the nice introduction. Like already described, I work for PERI's 3D construction printing department, and we print houses, we print buildings, and we claim that you have to rethink construction. I want to begin with a very provocative statement, and it goes the following. In the last 70 years of construction history, not much has changed significantly. What you can see on the screen are two pictures. One is from 1950, the other one is from 2019. So we have roughly 70 years of construction history combined in two pictures. And it might sound a bit harsh, but in my perspective, I don't see any enormous differences between these two pictures. The biggest difference is one picture is colored, the other one is black and white. And what's the problem with that? The problem is that many other sectors have become way more productive over time. They integrated trends like digitization, like automation. And also for us in construction, we need to come up with any solution to close this productivity gap that we lost throughout the last years. And this is the reason why we came up with 3D construction printing, to not lose touch to the other sectors. In 2020, we believe that we have changed the construction site for good. We started to print the first fully permitted houses in Germany, and we believe that people and machine can work hand in hand together collaboratively, and this is displayed in this nice picture here. Let's talk about the main benefits when you are using a 3D construction printer. Why should you use it? First of all, it's time and cost saving. Due to the automated construction method, we have a lot of savings potential here. The system that we use here is from Danish startup Cobot, our partners here, and the maximum printing speed is 1 meter per second, which potentially can reduce the building time enormously. For myself, I have been to Austria to print Austria's first house that came out of a printer, and it was a single-story house or an office building with a surface of 125 square meters, and it took us 45 hours of pure printing time. That does not mean that the complete house was done in 45 hours. It still takes more time, definitely, but the pure printing time was 45 hours to do the whole shell. Secondly, design freedom. So for every architect now, his heart opens up, and he's now the opportunity to print structures or objects that were not known so far, or were just too complex or too expensive to build today. And what we can do, you can see it on the nice picture on the back, and we can do round shapes, we can do overhangs to a certain degree, and honestly, in my opinion, I love the design of this house, very futuristic, very modern, and we can do also print parts of interior design. We can print fireplaces or bathtubs, we've already heard that today, and there's more room for creativity. We printed the first buildings, let's see what comes up next. And therefore, we also claim that we need to rethink architecture. Third is addressing the lack of skilled workers. We provide a solution to address this huge problem that we have not only in construction, but overall. We don't want to put any construction workers out of their work. It's rather that we want to give them an additional skill set with which they can operate and steer out this printer with a tablet or with a PC. And this will dramatically decrease the physical labor today. And in particular, we want to get young people excited again about construction. So let's talk about our biggest milestones so far, which we did. I did not bring all of them, but a few. This picture should look familiar to you. This is what we have seen already twice. This is the first house that we printed. It is a fully permitted house. People can actually live in here. It has 2 stories. 160 square meters of living space. And like I already said, it's very modern, very futuristic, not so known for our eyes, let's call it like that, but possibly the architecture of the future. Secondly, we can see here Europe's biggest multi-family house that came out of a 3D construction printer. It has 3 stories. It has a surface or living space of 380 square meters. And this has rather, let's say, a conventional look. Yeah, not that futuristic like the first house. And this is just a common way of building houses, like having a lot of living space on a limited area. And this is what we also try to pursue in the second project that I've shown to you. And I brought a third project. This is the project I already talked about. That's the one from Austria. Here we printed like this office building with 125 square meters. And here you see a picture from the printing process. That means you can see how the printer is installed on the construction site. And the walls are not completed at all so far. But you can still see this nice flower design, yeah, which is used in here again.
Thanks a lot, Alex. So thanks a lot for the insights. And I think now I can think about an own printed house as well. 3D printing is reality. We see examples, we see that it's a technology which is still in development, but we see results. Alex, can you disclose some more details about what you have done so far, and where are the problems, the challenges you have faced during the construction of those houses?
Sure, definitely. So to sum it up, we printed 3 houses in Germany. One is in the US, and the one I talked about in Austria. And for sure, to start it, we are the pioneers in 3D construction printing, especially in Germany. So nobody tells us what needs to be done on the construction site. So we were the first ones to pull the machine on a construction site, pull it up, assemble it, and then get started. So we completely change the process on a construction site, and therefore we need to learn on our own. Yeah, and this, just is a huge learning effort that we have still right now. It's a young technology still, but we learned a lot throughout the first project, and this is the overall picture. To give you a more precise example, what we've done as well is regarding material management. Yeah, you have to imagine in the first project we had an empty silo, and there was one person dedicated to just fill in big bags of material to fill up the silo. And the problem was that the machine was faster printing the layers than the guy was by filling up the silo, and therefore we had to stop the machine. And stopping the machine is bad because it automatically increases the building time. And this was one of the major learnings in the beginning, that we need to come up with a solution here to bring a truck, for instance, that blows in the material in the beginning, then we have a silo, and then we can print out of a full silo. That was one of the major learnings in the beginning.
Yeah, I understand. Coming to another important topic for me. If I remember how many permissions I needed to get a carport on my on my ground installed, I can just imagine that there are a lot of regulations and let me say from this side something which is somehow hindering the construction of such buildings. Can you give us some insight on this?
Sure, very important point. Thanks for talking about that. First of all, there are no common regulations today in place how a 3D printed wall has to look like. Yeah, and therefore we had to do a lot of tests together with the Technical University of Munich to get permits on individual cases. That's what we achieved so far. So we have fully permitted houses, but not on common regulation, on common codes. But we did that on individual cases. That was definitely quite an effort in the beginning to achieve. But now, with the first houses that we have reference projects. And with these reference projects, we can always fall back on them for future projects, as we can say, okay, this printing wall has to look like the one from the last project. This area can be done with that approach from last time. And therefore, we expect the amount of time that you need for approval to decrease over time, definitely. And honestly, so far, the building authorities, there's good collaboration together with them, and they're not hindering us at all. Yeah, we have good collaboration, and therefore we expect also for the future to establish building codes for this matter.
I see, I see. And regarding the promise of productivity, if you, with your experience now, compare, let me say, the time you need to print a wall, a square meter of wall, or to make a square meter of brick wall. So, what is your take on it? So, what is what you found?
Yeah, thanks for the question. I get that asked quite often, to make that comparison. And honestly, for us, that's the wrong perspective. Because our goal is not to make a wall more efficient and say, okay, that's it. We have achieved everything. Our ambition is rather to decrease the whole building construction time. This is rather what we try to do. And therefore, our goal is to integrate all relevant traits on the construction site. And to give you an example, we do integrate the insulation in the printing process. We do integrate electric cabling on the construction site, that every other specialist that is needed on a construction site can save time. And saving time is always saving money. And this is rather the approach that we do. Like I said, we do also print parts of interior design. And therefore, we try to just reshape the whole construction site as we know it so far. That also means that also the planning is differently. So there's not just a new machine and we do similar houses. The whole approach changes more or less. And we've done it with the first projects. And we're looking forward for next nice challenges.
Yeah, okay. Very interesting. So it seems like that 3D printing is available, and it will get more and more available for all of us. I'm really looking forward to this. Alex, thanks a lot having you here, and thanks a lot for all the insights and having you answering questions in the chat as well. 3D printing is a new technology. It's impressive, and we will see for sure a lot more of this technology in the future. But can we use 3D printing all over the world? Can we use it in countries where we may face earthquakes, where we have maybe floods or whatsoever? So this is an important question. And let us have a look to South America. Let us have a look to Chile. Claudia Eugenin, she is an expert on the 3D sector in Chile, and she is somehow connecting the 3D printing even with the circular economy in Chile. Claudia, the stage is yours.
Hi, thank you for having me. Yes, I'd like to tell you today about how our research team here in Chile, we are taking environmental liability like mine tailings, how we see in the picture, and putting it through a process that makes it printable and a resistant material. So our research team here from Pontificia Universidad Católica de Chile, we have found that the context for Chile is a good opportunity to make 3D printing with concrete more sustainable. So to begin, as you were saying, in South America and in Chile, we have, unfortunately, a very big necessity for social and emergency housing. And 1/3 of households in Latin America usually endure inadequate housing. And even in some countries like Bolivia or Peru, 70% of families have poor quality housing. So 3D printing with concrete or 3D printing for construction is an opportunity to improve this standard for social affordable housing. And specifically in Chile, we will have some local benefits. For example, 3D printing with concrete would improve productivity, which is otherwise not so efficient here in South America. Also, it is an opportunity to make cheaper, lower CO2 concrete construction. And it is also faster to build and more durable than the otherwise wooden or timber emergency housing that we usually use here. However, we also have some local challenges, how you were mentioning. Chile in particular has a very restrictive building code that usually requires reinforced concrete to withstand seismic solicitations. Also, some of the admixtures that we usually have to use in 3D printing are not always available here in Chile or in nearby markets. And also the workforce in the construction is generally unqualified for example, a technology that requires engineers or a more qualified workforce. So the work plan that we are choosing to follow to confront these obstacles are to start with the mixed design of the printable concrete, then going into the structural design to see how it can withstand the seismic solicitations, even if it is 3D printed. Then going to the architectural design, focusing mainly on the comfort of the user, then into the insulation so that the printed structure can withstand climate, can be isolated acoustically, can be fire resistant. And finally, we will go into a prototype construction where we will monitor the behavior of this printed house so that in the end, we can have technical specifications tailor-made for the Chilean context and a special technical design and the constructive methodology that anyone can follow in Chile. And specifically in this first phase where we are currently, we have been exploring alternative binders such as mine tailings, clay, and alternative aggregates, which are also in lacking all around the world. We have not as much access to aggregates as we had before. So we think it is important when developing this type of technology to follow a sustainable agenda, starting with going local. We think that using local materials will promote the growth of our local industries and reduce the total CO2 footprint of the materials that we are using. So our team specifically, we are taking advantage of pozzolanic cement, which is what we have in a high quantity here in Chile. And the pozzolanic cement actually promotes a slower hydration process in the concrete, which is good for 3D printing as it provides a longer open time. That is, it stays malleable and workable for a longer time than a normal cement. We are also very focused in staying circular, being sustainable. We see a value in using byproducts or waste products from other industries, such as cement replacement, filler, or aggregate. And we have seen that these things can sometimes promote better printable rheology and better durability. So specifically our team, we are exploring the use of processed mine tailings as cement replacement or aggregate. And for example, here in this picture, we have a small scale printed model for a housing unit using cement paste with 10% raw mine tailings as cement replacement. Furthermore, we can also use the tailings either in a cementitious concrete, which we see here on the left, or a geopolymeric concrete, which we see here on the right, with the aggregate that is in the concrete also made 95% of pure tailings. So it is almost 100% tailings concrete. And we're also very focused in going affordable. We know that this has to stay accessible, especially in countries like ours. And we think that the way to do this is to reduce the cement dosage in the printable mix and also reduce the dependency on some unusual admixtures that are sometimes not accessible here in South America. So our team, what we are doing is exploring the use of air entraining agent as a rheology modifying agent, and also a buildability enhancer for 3D printing without increasing the cement dosage, and therefore without increasing the cost of this cement or the CO2 footprint of this cement. So this is a little bit of what we are doing here in Chile.
Thanks a lot, Claudia. very interesting and very informative. Cement printing, concrete printing in South America. It looks like it has a big impact on the country as well. Claudia, if you look into Chile today, if you look into in the lack of existing housing, especially in social housing, what is your take on it? How 3D printing can support your country?
Well, we think that concrete 3D printing is a very good option for this emergency or social housing, because what we need here specifically is speed and durability. What we are doing right now, what the market does here in Chile, is build fast houses, prefabricated but made of wood or timber, which is good for building it quickly. But it's not durable in time when you compare it to concrete, which is a material that can last up to 100 years. It seems like a better option that can provide protection and a place to live for a longer time and in a better quality than what we are using right now.
Yeah. Let me come back to earthquakes. Earthquakes. So I think really something which is affecting Chile and other countries in South America a lot, or even around the world. So what is your take on the impact of such earthquakes to the 3D printing industry?
Well, yes, it's something very important to consider. As I mentioned, it is the second phase of our work plan, because specifically in Chile, we have very restrictive building codes that usually do not permit concrete without reinforcement. So in the current state of the art of 3D printing, there is not just one solution for making 3D printing also earthquake resistant, but some things that have been explored are, for example, printing with fiber inside the mix, polypropylene fiber or steel fiber that provides a better traction resistance. Also that you can leave spaces in the printed structure where you can, after the printing, introduce the reinforcement in strategic places that would provide this seismic resistance. Of course, this all has to be tested, and experimental designs have to be made for the different methods, but there is definitely a solution for this, and we are definitely looking into it.
Okay. You have touched in your presentation circular economy, and it looks like that you want to somehow match the mining industry with the 3D printing. What are your ideas on this?
Yeah, our research team here saw an opportunity, considering that Chile and many countries in South America have a very big mining sector, which produces a lot of mine tailings. So we saw this opportunity to hit two birds with one stone, because we can take the material, which is a waste material that is otherwise forgotten, or can even pose some problems in the communities that are nearby these mine tailing deposits. And we can take that material and reduce that liability, and also fix the problem of not enough aggregates in the world, or specifically in Chile, we don't have as much aggregate as we had before. And also reducing the impact of these construction materials. So we are reducing the impact of the mine tailing in the mine tailings, and also reducing the impact of the construction materials. So we think it is a very good idea, and it has shown promising results up to now.
Thanks a lot, Claudia. I'm really looking forward to see you in bauma this year in October, And I would be really glad to hear more about your researches and more about Chile. Thanks a lot for your nice presentation and your good answers. Thanks a lot.
Thank you.
Now we are already at the end of our first bauma talk. Time was flying, at least for me, I hope for you as well. I hope that you have enjoyed it. And please remember, all the experts, they are still available for you, like Claudia. You can ask your question, you can raise them, and you can somehow get it from the experts. I hope to see all of you in bauma in October. And please stay tuned, watch the other webinars to become, the other bauma talks. And yeah, I wish you all a nice day and hope to see you soon again. Bye-bye.